All right, so you should have solved these and tried graphing them. We'll go through them so that we can check our answers. So we're going to start. This is an and, or a conjunction, so we're going to solve from the inside out. And we'd be left with -1 is less than -2x, which is less than 2. We can divide by -2 to both sides. Because we're dividing by a negative, the inequality symbol is going to have to flip on both sides. So we're going to have 1/2 is greater than x, which is greater than -1. So you could write this as x is less than 1/2 and x is greater than -1. That might help you. It might make it easier to graph. It might not. You don't have to write it like that. It just could help. So we'll start graphing. Let's say 0, 1, 2, 3, and 4. -1, -2, -3, and -4. Again, we're going to start by graphing both inequalities, and we're going to look at where they overlap. All right, so let's graph x is less than 1/2, so an open circle at 1/2, and we're going to go to the left. And x is greater than -1, so an open circle at -1 going to the right. And where they overlap is right in between these two parts. So I'm going to graph this in blue. So we'd have an open circle at -1 with a line to an open circle at 1/2, and this blue part is the only part we would graph. We wouldn't want any of this red, so I would erase that red part and erase this green part, and I would only have this part right in the middle. Alright, so let's look at number 2. Number 2 is or, so we can have one solution or the other that does not have to satisfy both, so we'll solve both inequalities. Can add 5. We get 2x is less than or equal to 12. Divide by 2 and we get x is less than or equal to 6. And again, we can solve on this side. So we have -2x is greater than 8. And if we divide by a negative, again, we're going to have to flip that inequality sign. So we have x is less than -4, and this is or. Right, so it can satisfy either inequality. So we'll draw our inequality, or our number line. And we'll say 0, 1, -1, -2, -3, -4. Well, we need to have it go to 6. Sorry, let's try this again. I was thinking that was a -6, not a +6. I have -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and 6. Alright, so we have x is less than or equal to 6. So we have a closed circle at 6. Or x is less than -4. So we'll have an open circle at -4 going here. Because it can satisfy one or the other, if we look at this x is less than 6, it includes this x is less than -4. So we don't even need to graph this x is less than -4. All we have to do is graph x is less than or equal to 6, because it will satisfy both of those inequalities. So you'd only have this one red part right here to show the solutions for both of those inequalities. Okay, so let's try the next one. Again, or, so it has to satisfy one inequality or the other. Let's start by solving. We have 4x is greater than -8. Divide by 4. Because we're not dividing by a negative, we can still say the symbol stays the same way. So x is greater than -2. And then over here we can add 1. 3x is less than 12. We can divide by 3 and get x is less than 6. Okay, so and this is OR. Graph this here. So we'll have 0, 1, 2, 3, 4, 5, 6, -1, -2, -3. Alright, so let's start by graphing both inequalities. We'll graph x is greater than -2, open circle at -2, greater than, and x is less than 6 here. Now if you look at the solutions to both inequalities, you notice that the whole number line is filled. Up in example 3, we stopped at 6 because that was the largest number that satisfied the solution. It was anything less than it. However, with this inequality, we have solutions both to the right and to the left, so we would graph the solutions to this as the whole number line, because all numbers could be a solution to one inequality or the other. So we would just graph that blue part, and this would have all reals as the solutions. All right, let's look at number 4. Number 4, we would solve. Again, it's an OR, so we'd solve both sides. We add 5. We get 2 is less than or equal to 2x, and divide by 2 and get 1 is less than or equal to x. And we can add 4. 9 is less than -3x. Because we're going to divide by a negative, we have to flip the sign. So -3 is greater than x. And we could rewrite that as x is greater than or equal to 1, or x is less than -3. So let's graph that. Alright, so we'll start graphing x is greater than or equal to 1. So here's 1, close circle at 1, pointing to the right. And then an open circle at -3, pointing to the left. Again, because it's OR, solutions can satisfy one inequality or the other, so they do not need to overlap. So we leave the inequality just as it is with the two lines going both directions. Okay, let's look at number 5. Number 5, here we're going to solve from the inside out because it's and, so it has to satisfy both inequalities. We can add 5 to both sides. We get 12 is less than 2x, which is greater than 16, and we divide by 2 and get 6 is less than x, which is greater than 8. We could also write this as x is greater than 6 and x is greater than 8. So when we graph that, let's start maybe at 3, 4, 5, 6, 7, 8, 9, 10. Let's start graphing x is greater than 6, so open circle at 6, going to the right, and then x is greater than 8 here. Now because it's an and, they have to satisfy both inequalities, so you want to see where the two inequalities overlap, and that is going to be just greater than 8. That's where both of them overlap. So the only part we will graph for this inequality is the x is greater than 8, because both the solutions have to satisfy both inequalities. So you would not have any part of that x is greater than 6, that first part, only x is greater than 8 there. Alright, the last one we're going to do is another and, so we're going to solve from the inside out. And we have 20 is less than -5x, which is less than or equal to -10, and divide by -5 because we're going to divide by the negative. We're going to have to flip the inequality symbols. So we have -4 is greater than x, which is greater than or equal to 2. Okay, so we could write this again as x is less than negative 4 and x is greater than or equal to 2. So let's graph this 0, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4. Alright, so let's graph x is less than negative 4. And we can graph x is greater than or equal to 2. Now, because this is an and, you need to look at where the graphs overlap. Well, you'll notice that they don't overlap anywhere, that there will be no solutions that are the same, so there are no solutions to this inequality. So you would not graph anything. You would have nothing on this graph. So you wouldn't have the purple or the red because you cannot graph it. There are no solutions. So in this case, our answer would be no solutions. So make sure that you look through these notes. We'll do some practice in class. What I want you to do is write a summary recapping what you have learned and the differences between your compound inequalities using and or. See you soon.